Okay, we're talking about direct and inverse variations, right? I said that before we've actually dealt with direct variation before. I just want to review direct variation. And you may want to, on the back, write this down just to help remind yourself, make notes. Direct variation, the equation is y equals kx. Okay, the way we've known it, we've learned this before, is direct variation is the same as that's not pro, try it again. Proportional. Remember, proportional means that the constant is 0, that it goes through the origin. Okay. The K is basic. The K is basically our coefficient. It's our slope. That's what that number is. This is the amount that we're increasing by each time. An example of direct variation, an example would be an hourly wage. It would be like if I told you that you were going to make $10 per hour. Because every hour you're making the same amount. Okay? That means that when we look at a table, every time we look at the y's, each time it goes up by 1, it's going up by the same amount. Now, would I mean that we've done this before? This is what I was thinking about. Look at this problem right here. This is actually off of a sheet we did way earlier in the year. This is not on your sheet that you're flipping back over, so keep it on the blank side. It says Barney is ordering lunches for referees at an all-day basketball tournament. The total cost of the lunches varies directly. See, we've actually already used this vocabulary before. With the number of lunches purchased. 5 lunches cost $35. Complete the table and write the equation that represents C, the total cost C, in terms of the number of lunches. Okay, if 5 lunches cost $35, how much does each lunch cost? 7. How did you get that? You took 35 and you divided it by 7. Okay? So 35 divided by 7 is 5. Right here, 5 lunches is $35. Hold on. Let's go back. What was I saying? I got everybody walking in, and so I got confused for a minute. 35 lunches divided by 5 equals $7. Now, that's 7. So 1 lunch is $7. What would be my equation? Y equals 7x or n, because you're taking $7 times each lunch. So now if I had to finish my table, I would just take 15 times 7. Well, and really, maybe it's easier to see if we did this. 1 lunch costs $7. 2 lunches cost what? 14. 3 lunches? 21. 4 lunches? 28. This is when everything is just the same amount. We're increasing or decreasing by the same amount. So let's look at this next one. Right here. Maybe you may have already seen this. Here we go, but I'll cover this up real quick. Don is ordering ostrich print boots for all the managers at a Justin Boots promotion. The total cost of the boots varies directly. That's Y equals KX with the number of boots purchased. 6 boots cost $1,200. This K right here in this direct variation, that's going to be how much each boot cost. So how much is each boot? How do you get, some of you guys are telling me, how do you get the cost of the boot? You divide. You take 1,200 divided by 6, not 66, divided by 6. That's $200. So your equation would be y equals 200x, because for each pair of boots, it increases by $200. So if I made a table, I want you looking at these tables. If I made my table, one pair of boots cost $200. Two pairs of boots cost $400. Three pair of boots, $600. Four pair of boots, $800. Now, remember, I said when we were trying to identify those tables yesterday, okay, to figure out what K is, to figure out what that coefficient number is, I was telling you guys to divide it by X. So it was saying that K equals Y divided by X. Well, what is 200 divided by 1? 200, right? 400 divided by 2. 600 divided by 3. 800 divided by 4. That's why this is happening. This is a direct variation. Take a minute, and I want you to fill out the table for this one. And actually, I want you to make a table not with these numbers. I want you to go ahead and use the numbers 2, 3, and 4. Please do this problem right now. In this case, it says Lori is ordering necklaces for the players in her soccer club. The total cost of the necklaces varies directly with the number of necklaces she purchases. See, look, total cost varies directly with the number of necklaces. Y varies directly with X. 11 necklaces cost $33. Well, if you take 33 divided by 11, how much does each necklace cost? $3. So one necklace costs $3. Two necklaces, $6. Three necklaces, 3 times 3 is 9. And 12. Again, Y equals 3X. To figure out this K, we said that you take the Y, to find your K, we take the Y number divided by the X. Well, the total cost divided by how many you're buying. 3 divided by 1 is 3. 6 divided by 2 is 3. 9 divided by 3 is 3. That's direct variation. Okay? Now, inverse variation. Inverse variation is Y equals K divided by X. Okay? I told you in a table there to find your K that you are going to have to divide by, or not divide, multiply by the numbers, right? I said that if we had, we'll look at our tables in just a minute. But in this case, look, if I want to get K by itself, if I want to get rid of this X and move it up here, so K is by itself, it says divide by K. We know that in solving equations, to get rid of it, we have to do the opposite, which is multiply. And you have to do that to both sides. This is the same as X over 1. Well, these X's cancel each other out. So I get X times Y equals K. Okay, now wait, you look confused. So now the question is, you need to talk to me and tell me, what are you confused about? We're trying to isolate and get K by itself. We're trying to solve and get it alone. The equation right here in the black, we have K divided by X, right? I need to get rid of the X. So here's what I would say. Y equals Say we have x divided by 2. If I was just solving this equation, or let me just even make it this. Let's put an 8 over here. If this was our equation we were solving, and we had to find out what x was, how would you solve it? What would you do? You would multiply by what? X divided by 2. You would multiply by this number down here. You would multiply by 2 to both sides. 8 times 2 is 16 equals these 2 cancel out equals x. That's what I'm doing right here. Same thing. The difference is we're just keeping letters. All right, let's go back and look at something. Let's look at a table. This might help us too. Okay, direct variation. Y equals k divided by x. So in a table, if x is 1, let's see if I can come up with an example here. I got to figure it out for a second. Hold on. What if on this one for direct variation, we came up with the equation? We're going to want to find the equation, but later on. But if we have y equals 12 divided by k, okay? If x is 1, and I totally am writing that backwards. Let's try this again. Y equals k, which is 12, divided by x. If x is 1, 12 divided by 1 is 12. If x is 2, 12 divided by 2 is 6. If x is 3, 12 divided by 3 is 4. If x is 4, it's 3. Okay, 5 doesn't go in there evenly. I'm going to skip that for a second. What about if it was 6? 2. 7 didn't go in there evenly. 8 didn't go in there evenly. 9. The other one is 12 and 1. Basically, it looks like in this case I have factors, but that's because I'm going with the whole numbers. Okay? What do you notice about these numbers? About the x and the y's? Okay, so look, x is 1, y is 12. X is 12, y is 1, right? Inverse. They're the same numbers, they're just flipped, right? That's because right here, if I was trying to get the 12 by itself, that's when I was saying that we would have divided each side by x. I'm sorry, multiplied. X times y equals 12. That's when I said you multiply these two together in a table, and if they equal the same amount, that's an inverse variation. Okay? So let's look at the paper that you guys have. Oh, let's go back to number 1. It says, suppose your pay varies directly with the number of hours you work. That means it's proportional. It means that you're getting paid the same amount every time. Your pay for 7.5 hours is $45. Write a direct variation equation. Well, wait. So let's see. We've got hours and we've got our pay. 7.5 hours is $45. How much do they get paid each hour? How do I find out how much they get paid for 1 hour? Take 45 divided by 7.5, which is, you said 6? Not that I don't trust you. Yes, it is 6. Okay, so my equation is y equals 6x. That means that you get paid $6 an hour. Now it says find your pay if you work 30 hours. Y equals $6 times 30. So you're going to get $180. Take a minute and try the next one. This time it varies inversely. All right, in this case it says the pitch of a musical note varies inversely with the wavelength. If the tone has a pitch of 440 vibrations per second and a wavelength of 2.4, find the pitch of the tone that has a wavelength of 1.6. Okay, so let me see. I'm going to make my table. Sometimes it's easier for me to always either draw a picture or make a table. Let's see. The pitch varies inversely with the wavelength. So I've got the wavelength and the pitch. So it says if there's a pitch of 440 vibrations, per second and a wavelength of 2.4, find the pitch of the tone that has a wavelength of 1.6. You know, I look at this and I'm thinking about the way that you guys learned in middle school. You could almost set this up as a ratio or a proportion. That's basically what you're doing. Okay? So what we're doing here, so right now we need to go and I need you to multiply these two together. Remember, varies inversely is y equals k divided by x. To find k, you need to multiply these two numbers. So I need you to take 440 times 2.4. 440 times 2.4 is 1,056. Now, since these two numbers multiply together to get this number, if I have this one, see, really it's y equals 1,056 divided by x. Well, what we need to do is put 1.6 down here. So you just need to divide by 1.6. So now we divide by 1.6. And what do you get? You should get 660. That's what we're doing with varies inversely. Number 3. If you're watching the video, you can pause the video. Otherwise, you can't. I need you to try and do this one right now. It says that the Ramirez family is driving cross-country on vacation. They drive 330 miles in 5.5 hours. Write a direct variation, y equals k times x, to find the distance driven after so many hours. Well, direct variation right here, we've got hours and we've got miles. In 5.5 hours, they drive 330 miles. Well, basically, it's saying how fast, we need to find how fast they're going to write our equation. That's what this k is going to be. So we take 330 and divide it by 5.5. You said it's what? It is 60. See, there's an equation, too, that goes along with something like this that says rate times time equals distance. Do you recognize that formula from science? The time is 5.5. So we don't know the rate. Times 5.5 equals 330. We're dividing by 5.5 to find R. And R, the rate, is 60. Another way to look at it. Same thing that we're doing. So y equals 60 times x. Estimate how many hours it would take to drive 600 miles. 600 goes right here. So I have 600 equals 60 times x. How do I find x? I divide by what? Divide by 60. You divide by the number that's with the x. So what does x equal? 10. So it would take 10 hours. The next one. Here's the next one. Take a second and try and figure out these two problems. On this one, it says, suppose y varies directly as x. Write a direct variation, y equals kx, that relates x and y, then solve. So for number 4, all right, here's my tables. Let me draw them for 4 and 5. There we go. All right, number 4. X and y. It says y is negative 16 when x is 4. Find x when y is 20. Well, just try and write an x is 4. There we go. How did I say we find our, when it's a direct variation, what do we do with the x and y numbers? We don't subtract, we divide. So I'll take negative 16 divided by 4, which is negative 4, right? So my equation is y equals negative 4x. If y is 20, 20 equals negative 4 times x. Divide by negative 4. What does x equal? Negative 5. Because what we're supposed to be doing is taking the y divided by the x. So negative 16 divided by 4 is negative 4. 20 divided by negative 5 is negative 4. That's what it means to be a direct variation. On number 5, when y is 4, x is 12. Find y when x is negative 24. Well, you're supposed to take the y number divided by the x. So I'm going to take 4 divided by 12. One of the biggest mistakes I constantly see is people tell me this is 3. It can't be 3. The top number is smaller. Not, well, yes, if we divide it, we'll get 0.3 or 1/3. Remember, if you don't remember how to do that in the calculator, you can take 4 divided by 12 and press math, enter, enter. And it will reduce the fraction for you. So my equation is y equals 1/3 x. They say when x is negative 24. So y equals 1/3 times negative 24. Multiply these together, you'll get y equals negative 8. Here we go, 6 through 8. Take a minute and try and do this one. It says write an inverse variation, inverse that relates x and y. Y equals k divided by x. So try that right now, and let's think about what we've talked about with inverse variation. All right, as I look at number 6, okay, so I'll do 6 over here. It says when y is 8, x is 1.55. Find x when y is negative 0.62. To find your k, you need to multiply the x and the y. So let's multiply these two numbers right here. I've got 1.55 times 8. That gives me 12.4. My equation is y equals 12.4 divided by x. Right? Multiplying these two together give me my k. Now, if to find my x, it doesn't matter right here. These two can swap places. What you're going to do is you're going to take 12.4 and divide it by negative 0.62. So if I divide it by negative 0.62, I get negative 20. So to prove that I'm right with what I'm doing right now, if you multiply these two numbers together, you get 12.4. If I multiply negative 20 times negative 0.62, I'm still going to get 12.4. That's how I can know I'm right. So in this case, x equals negative 20. Number 7, x and y. When y is 12, x is 5. Find y when x is 3. Okay, let's find our equation. Let's find our k. Multiply 12 and 5. What's 12 times 5? 60. So my equation is, well, my k is 60. My equation is y equals 60 divided by x. They're telling me they want to know what is y when x is 3. Well, what's 60 divided by 3? Y equals 20. Well, what is 3 times 20? 60. My answer up here is y equals 20. Number 8, x and y. When y is 7 and x is negative 2, find y when x is 7. Now, if some of you see here and understand what's going on with inverse, you shouldn't have to do anything right here. Inverse variation, if I find my k, if I take negative 2 times 7, what is it? Negative 14. What do I have to multiply by 7 to get to negative 14? Negative 2. Inverse. These things just swap places. So my y is negative 2. You can go through and do all this, but if you understand, like right here, on number 7, if I wanted to find some more points that varies inversely, if x is 12, what's y? 5. If x was 20, what's y? 3. They just switch places. Let's look at these next ones. Right here, we don't have to do any of that silly math number stuff. We just have to figure out if it's a direct variation or an inverse. The cost of $20 of gasoline is split among several people. Okay. The cost of $20 work of gasoline, not quite sure what that means. Let's see. Let's try and rewrite this a little bit. The cost of $20 of gasoline is split among several people. Okay? If we divide it between everybody, are we all going to pay the same amount? If we're all going on a road trip, the gas is $20, which, by the way, I wish I could go on a road trip for only $20. And 5 of us are going, we're all going to split it up and share the same amount, right? And if there's 10 people, we're all going to split it up and share the same amount. Since we're dividing it equally, everybody's paying the exact same amount. This is a direct variation. Number 10, you buy several markers for 70 cents each. Is the price staying the same for every marker? It's staying the same for every marker. This is a direct variation. Because each time, like my equation right here, would be y equals 70 cents times x. You are in a discount store. I don't know why it's got to be a discount store. Maybe they just have cheap sweaters. All sweaters are on sale for $15 each. Do you pay the same amount for each sweater? Yes. That is a direct variation. What would be the equation? Y equals 15x. Because you're paying $15 for each one. You walk 5 miles each day. Your speed and time varies from day to day. Are we walking the same time or speed? No. The only thing that's staying the same is the distance, right? So we don't know, they don't always stay the same. But I know, like when we talk about distance equals rate times time, all I know is that the 5 stays the same. Okay? In this case, these things can change. This is an inverse variation. What does an inverse variation graph look like? Do you remember? It has all those crazy looking curves. Because like if you put in an example, y equals 4 divided by x, you could be able to see that in the calculator. Remember, it's going to be these crazy looking curves. Are they ever going to touch the x and y axis? No, because when you divide, you can't divide by 0. That doesn't exist. So that's why it can't touch. So this is an inverse variation graph. What does a direct variation graph look like? It's linear, and it goes through the origin. So it can be a number of things. I can have it be, does it have to just be like this? No, it could be, we could have it decreasing. It could be at different slants, different steepness, as long as it goes through the origin. That is a direct variation. Okay, it was pointed out to me, which is true. Number 9 is incorrect. It is not a direct variation. A direct variation would mean if I had 1 gallon of gas, it would be $20. 2 gallons of gas, $40. It would be something like that. This is not what's going on number 9. On number 9, oh, I didn't mean to have that line. That's all right. We'll make it like that. All right. On number 9, basically, if one person was going on the trip, they would pay $20. If 2 people were going on the trip, they would pay $10. If 3 people were going on the trip, you would take 20 divided by 3, which is 6.667. 4 people on the trip, they would pay $5. So basically, when you're multiplying these two together, it's all equaling 20. So number 9 is supposed to be an inverse variation. I apologize for that. I'm just glad we got it corrected.